Welcome everyone. Today's session focuses on KMO2, KTO1, which forms the foundation of production supervision. In this session, we will explore 1. Production principles 2, production methods 3, production processes 4, productivity and efficiency 5, management information systems MIS 6, supply chain and logistics 7, inventory management and MRP 8, labor, health and safety legislation. By the end of this session, you should understand how the entire production environment fits together and how your decisions as a production supervisor influence productivity, quality, cost, safety, and workflow. Let's begin by looking at the core principles that shape any production environment. Production principles are the rules, ideas, and practices that guide how work is organized and executed on the production floor. These principles help ensure that processes run smoothly, consistently, and cost-effectively. Let's start with principle of productivity. Productivity is about achieving the highest output with the least resources. This includes minimizing waste, optimizing cycles, reducing downtime, and ensuring employees are trained and equipped to perform effectively. Productivity also depends on workflow design, machine availability, material readiness, and team coordination. As a production supervisor, every decision you make affects productivity, from how you plan shifts to how you solve daily disruptions. 2. Principle of quality. Quality focuses on producing outputs that meet specifications the first time. This involves proper inspections, calibrations, SOP compliance, and disciplined behavior in following standards. Producing defective products leads to rework, scrap, delays, and increased costs. Quality is not something that can be inspected into the product. It is built into the process through consistency and correct methods. 3. Principle of flow. Flow refers to the continuous movement of materials, information, and work through the system. Good flow means minimal stoppages, clear routing of materials, reduced bottlenecks, and balanced workloads across stations. Poor flow causes congestion, delays, backlogs, and frustration. Supervisors must identify blockages early and correct them immediately. 4. Principle of standardization. Standardization ensures that tasks are performed the same way every time. Standard work reduces errors, improves safety, helps new staff learn faster, and ensures predictability. As production scales, standardization becomes critical. It ensures processes remain stable even when turnover occurs. Now that the principles are clear, let's look at the different ways production can be organized. Production methods describe how goods are manufactured. They influence cost, efficiency, flexibility, and quality. 1. Job production Bay A. Customized, unique products are made one at a time. Each job is different, requiring specific materials and instructions. Examples: specialized fabrication, custom parts, prototypes. This method enables flexibility but is slow and expensive. 2. Batch production. And its A products are made in groups or batches. Each batch follows the same routing and specifications. Examples: food processing, textiles, packaged goods. Batching improves efficiency but requires setup and changeover control. 3. Mass flow production. High volume, standardized products move continuously through the production line. Examples: automotive parts, electronics assembly. This method relies heavily on balance, sequence, and consistent quality of inputs. 4. Continuous production. Production runs 24/7 with minimal interruptions. Used for chemicals, oil, water purification, Electricity generation. Any downtime is extremely costly, so supervisors must maintain discipline, monitoring, and communication. With production methods understood, we now explore how production processes operate from start to finish. Production processes describe the step-by-step sequence used to transform inputs into finished goods. 1. Input transformation output model. All production follows this universal model. A. Inputs: raw materials, labor, equipment, energy. Capital B. Transformation: activities such as mixing, assembling, heating, testing. C. Outputs: finished goods, byproducts, scrap. Supervisors must understand each transformation stage to identify inefficiencies and risks. 2. Types of transformation processes: physical transformation, for example, machining, welding, assembly. Chemical transformation, for example, mixing chemicals, curing, fermentation. Informational transformation, for example, planning systems, MIS capturing. Locational transformation, for example, moving goods, logistics. 3. Supporting processes. These processes ensure production is smooth. They are A. Maintenance, B. Quality control, C. Safety systems, D. Scheduling, E. Materials handling, and lastly, 4. Process mapping. Process maps visualize how work moves through a system. They help identify bottlenecks, unnecessary steps, risks, and opportunities for improvement. Once processes are in place, the next focus is improving productivity and efficiency. Productivity and efficiency are core responsibilities of every production supervisor. Let's take a look at 1. Understanding productivity. Productivity equals output divided by input. This measures how effectively resources are used. Improving productivity requires balancing labor, machines, materials, and time. 2. Types of efficiency. Labor efficiency. Are employees performing at the expected pace? Machine efficiency. Are machines utilized properly with minimal downtime? Material efficiency. Is there excessive scrap, rework, or waste? Time efficiency. Are cycles optimized? Is time being wasted? 3. Factors that reduce efficiency are poor planning, lack of training, equipment breakdowns, material shortages, poor communication, unnecessary movements, poor housekeeping. And lastly, 4. Techniques to improve efficiency are 5S and workplace organization, standardized work, reduced changeover time, preventive maintenance, workflow balancing, visual management to monitor productivity and performance. Accurate information is needed, which brings us to MIS. MIS provides real-time and historical data to support planning, controlling, and decision-making. Production supervisors rely on MIS for 1. Output data 2. Downtime tracking 3. Quality results 4. Inventory levels 5. Labor utilization 6. Machine performance. Now let's take a look at benefits of MIS. They are as follows. Better decision making, faster problem solving, accurate reporting, data-driven planning, consistency across shifts. And lastly, MIS challenges supervisors must manage are incorrect data capturing, delays in reporting, incomplete information, lack of training, system errors. Supervisors must ensure that all operators and team leaders capture accurate and honest data. MIS connects closely with supply chain and logistics, which we cover next. Production depends on the flow of materials from supplier to warehouse to production to customers. Let's begin with 1. Supply chain components are suppliers, inbound logistics, warehousing, production, distribution, customers too. Role of logistics are transportation, receiving, storing, movement of goods. Dispatch 3. Importance to production supervisors are ensuring material readiness, preventing line stoppages, coordinating with procurement, communicating shortages, monitoring supplier performance. Production cannot operate without the right materials being available at the right site. Time. Once the supply chain is understood, the next area is controlling and managing stock levels. Let's begin by asking why inventory control matters. It matters because prevents stockouts, prevents excess holding costs, ensures smooth flow of work, minimizes waste and damage too. Types of inventory are raw materials, work in progress, finished goods, maintenance, repair and operating supplies. MRO3. Inventory control systems. First in, first out. FIFO. Last in, first out. Minimum, maximum controls. Reorder points. ABC classification. And lastly, introduction to MRP, materials requirement planning. MRP calculates what materials are required, how much is required. When they are required, MRP helps supervisors reduce shortages, delays, and unnecessary purchasing. Production supervision also requires understanding of legal responsibilities. Production supervisors must comply with 1. OHS Act 2, Labor Relations Act 3, BCEA 4, COIDA 5, Company SOPs 6, Environmental regulations. Key responsibilities include 1. Providing safe working conditions 2. Enforcing PPE compliance 3. Reporting incidents 4. Supporting investigations 5. Ensuring training compliance 6. Ensuring safe machine operation. Non-compliance has severe consequences, including injuries, fines, operational shutdowns, and reputational harm. Today's KMO2 KTO1 session covered the full foundation of production. Supervision. A. Production principles. B. Production methods. C. Production processes. D. Productivity and efficiency. E. MIS. F. Supply chain and logistics. G. Inventory management and MRPH. Labor, health and safety legislation. These concepts form the backbone of supervising a production environment and are essential for your EISA and workplace performance. A strong understanding of these areas allows supervisors to lead teams effectively, reduce waste, maintain quality, and support organizational goals. Thank you for your attention and participation today.